Okay, so let us start successive differentiation. So let me give you the idea. First of all, we already know if the function looks like, suppose y equal to uh, x to the power n. First thing, y equal to x to the power n. Then y1, as you know, n x to the power n minus 1. y2 equal to n times n minus 1 times x to the power n minus 2. Y3 will be similarly you can do y3 y4. So generally yn will be n time n into n minus 1 n minus 2 into 1. So it is actually factorial n, and onwards derivatives yn plus 1 yn plus 2 onward derivatives are all 0. Suppose the function looks like y equal to 1 by x minus a. So y1 will be minus 1 by x minus a whole square. y2 will be minus 1 times, actually it is minus 1 square into 2 by x minus a whole cube. y3 will be, when you complete y3, the picture will be clear that it is actually 2 into 3 divided by x minus a whole to the power 4. And similarly, if you can find y4, it will be minus 1 to the power 4, 2 into 3 into 4 divided by x minus a to the power 5. Similarly, I can write yn as minus 1 to the power n into factorial n divided by x minus a to the power n plus 1. On the other hand, if I take another function, suppose y equal to sine ax plus b, suppose sine ax plus b. So we know that y1 is a times cos ax plus b, and this can be written as a into sine pi by 2 plus ax plus b. So in this way, I can write y2 as a square into sine 2 into pi by 2 into plus ax plus b, and hopefully I can get yn as a to the power n sine n pi by 2 plus ax plus b. Okay, let's continue. This is yn. Similarly, I can write number 4 as y is cos ax plus b. So I can write directly that yn, nth order derivative of y, is cos of, first of all, to the power n will occur, then n pi by 2 plus ax plus b. So this is, we already know. After that, something we need to know, what is Leibniz theorem. So Leibniz theorem: if u and v are two functions of x, then u into v, if I make derivative of nth order, the answer will be unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus ncn uvn. Something like it is similar to the binomial formula. It is similar to binomial formula a plus b whole to the power n equal to a to the power n plus nc1 a to the power n minus 1 into b plus nc2 a to the power n minus 2 into b square plus dot 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 plus ncn. ncn is already 1. ncn is always 1 a to the power b to the power n, only b to the power n. So it's similar to the formula of binomial, so it's easy to remember. And one thing we should note that nc1 is always n, nc2 is always n into n minus 1 by 2, nc3 equal to n into n minus 1, n minus 2 by 6, and this is factorial 3. Actually factorial 3 is 6, and of course ncn is always 1. Okay, now let us give you some idea how to use this formula. Suppose it's given that y equal to x square into sin x. It is given to you y equal to x square into sin x. So how to find out the nth order derivative of y? How to find out the nth order derivative of y? So first of all, you need to choose that can be u, that can be v. So if I look back to the formula, that the derivative of v is increasing, the derivative of u is decreasing. Derivative of u, so let me write the formula again, that uvn equal to un times v plus nc1 un minus 1 times v1 plus nc2 un minus 2 v2, and this way the formula is going. So first observations are derivative of u are derivative of u is decreasing, and derivative of v is increasing. So it is better to choose x square. It is better to choose, if I go back to the problem, y equal to x square sin x. If I ask you which one should be u and which one should be v, first answer is anyone can be u, anyone can be v. But for the simplicity, if I take v as x square and u as sin x, then we need not write, we need to write just finite number of terms, because derivative of suppose v is x square, v1 will be 2x, v1 will be 2x, v2 will be 2, and v3, v4, v4, v5, v6 all are 0. So we need to write only 3 terms, 3 or 4 terms. Okay, so but if I take u as x square and v as sin x, it is not that it contains finite number of terms. It can be n number of terms or more than finite number of terms. So whenever a polynomial occurs, so let me write that when we should choose polynomial as polynomial function as v. So back to the problem, that y equal to x square sin x. So this is so let me write sin x times x square. This is your u, this is your v. So yn will be un what was the formula, un into v, un into v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus nc3 un minus 3 v3. So just I am right, un is sine n pi by 2 plus x, that's all, because u is sin x and v is x square. Just put v is x square, so this into x square plus nc1 is n times un minus 1 sine n minus 1 times pi by 2 plus x into 2x plus nc2 is n into n minus 1 by 2 into un minus 2 is sine of n minus 2 times pi by 2 plus x into v3, sorry, it is v1 v2, so it will be 2, and after that derivative of 2 is 0, so this is the last term, and after simplification it will be something like x square into sine n pi by 2 plus x plus 2nx sine n minus 1 times pi by 2 plus x plus, so 2 will be cancelled, it will be n into n minus 1 into sine n minus 2 times pi by 2 plus x. So this is the way to find out nth order derivative. Now I am solving a problem. It is given that if y equal to sine inverse x whole square, then show that first 1 minus x square times y2 minus x y1 minus 2 equal to 0, and number 2 is 1 minus x square into y n plus 2 minus 2n plus 1 into x y n plus 1 minus n square y n equal to 0. So this is given y equal to sine inverse x whole square, and we need to prove 1 and 2. How to give the solution of this problem? First thing, it is given that y equal to sine inverse x whole square. Okay, so differentiating both sides, differentiating with respect to x, we get y1 equal to 2 sine inverse x into derivative of sine inverse x is what? Yes, I guess. Okay, I think everybody knows that derivative of sine inverse x. So root over of 1 minus x square into y1 equal to 2 sine inverse x. Squaring both sides, we get what? 1 minus x square into y1 equal to 4 sine inverse x whole square. Actually, sine inverse x whole square is y, so I can write it is 4y. So let me write the last result, that 1 minus x square into y1 equal to 4y equal to 4y. Look at the first proof. The first proof contains y2. So we need to derivative more. So we need to differentiate more. So again differentiating both sides with respect to x, we get 1 minus x square times this, that will be y2 plus y1 into minus 2x equal to 4y1. That is 1 minus x square into y2 plus minus 2xy1 equal to 4y1. Anything wrong?
So it will be y1 square.
And yes, it will be y1 square. So it is wrong actually, y1 square. So let me do it again. So 1 minus x square into derivative of y1 square is 2y1 into y2. Okay, 2y1, y1 derivative of y1 square is 2y1, and again differentiation on y1 is y2. So it is first function derivative of the second plus y1 square into derivative of the first, that is minus 2x equal to 4y1. Okay, I think now it is correct. So 2 is the common factor to every term, so I can delete 2. So it is 1 minus x square, and I can delete y1 as well. So 2y1 I can divide every term by 2y1. So 1 minus x square into y2 minus 2x, so 2, there is no 2, 2 minus xy1 equal to xy1 equal to 2. Okay, I think this is the first question. Yes, 1 minus x to y2 x y1 minus 2 equal to 0. So to prove second, we need the complete expression of 1. So let me rewrite the complete expression of 1. So what we have 1 minus x square into y2 minus xy1 minus 2 equal to 0. So look at the second problem. Second problem is 1 minus x square times yn plus 2. That means if y2 is already here, and if I make nth order differentiation on y2, what will be the result? Nth order differentiation on y2 will be yn plus 2. Nth order differentiation on y3, it will be yn plus 3. So if we already have y2, if I make nth order differentiation on this term, so there is a chance to have this term. That means all I need to do to differentiate this expression n times. That's all. So I already told you this choice will be v, always it will be v, it will be u, it will be v, it will be u, and this is constant. So on differentiation, n times, and applying Leibniz rule, we get. So let me just write uvn equal to un v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus nc3 un minus 3 v3. This is the way to write the Leibniz rule. So The first expression, this will be your v, this will be your u. I already told you why it is the choice. So the answer will be v into, so v will be remain unchanged, so 1 minus x square times un. So if it is your u, so un will be what? Anybody having any idea? Apply nth order. Okay, let me write in this way, y2 nth order minus xy1 nth order minus 2 nth order equal to 0. Okay, so I can write, this is your u, this is your v, this is your u, this is your u, this is your v, this is your u, this is your v, this is your, there is nothing, the derivative of 2 is 0 always. So I am going to write the answer according to this formula. Tell me, what will be the first term?
yn plus 2 into 1 minus x square.
Exactly. Yn plus 2 into 1 minus x square plus nc1 yn plus 1 less derivative of v is always decreasing, yn plus 1 into minus 2x plus nc2 into yn into minus 2. After that, all the derivative will vanish due to the term minus 2. So this is done. After that, second term is yn plus 1 into x, so minus, there is a minus sign, plus nc1 yn plus 1 yn into 1, and then there is nothing, equal to 0, because derivative of 2 is 0. Okay, any doubt to anyone for this line? So on simplification, yn plus 2 1 minus x square into yn plus 2 minus yn plus 1. Now I want to take all the yn plus 1, so it is oh, first of all you need to put nc1 and nc2. Let me put that first of all, after that I will take common. So this is n into 2xn into y plus 1, 2xn into yn plus 1. After that, nc2 n into n minus 1 by 2, nc2 is n into n minus 1 by 2, and these two will cancel to each other, so it is only yn into n minus 1 into yn, plus, it's plus or minus n into n minus 1 into yn. Minus x yn plus 1 minus x yn plus 1 minus n yn equal to 0. So this is the full expression. So 1 minus x square into yn plus 2 minus yn plus 1 x into yn plus 1 into 2n plus 1 minus yn into, this is n square minus n plus n equal to 0. So I can get 1 minus x square into yn plus 2 minus 2n plus 1 into x yn plus 1 minus n square yn equal to 0. I think this is the last expression of the second problem. So in this way you need to prove in your exam this type of question will come. So I need to solve one more question. Okay. If y equal to e to the power m sine inverse x, show that 1 minus x square into yn plus 2 minus 2n plus 1 into x yn plus 1 minus n square plus m square into yn equal to 0. First thing, to prove this result, the first term indicates that we need to find out y2, then we need to differentiate n times on y2. Okay, because yn plus 2 will occur n times differentiation on y2. Yn plus 2, this will occur n times differentiation on yn, sorry, y2. So we need to find out this y2 from this expression. So it is given that y equal to e to the power m sine inverse x. So what is your y1? y1 equal to e to the power m sine inverse x, and derivative of m sine inverse x becomes derivative of m sine inverse x becomes m times root over of 1 minus x square. My suggestion is, whenever you are having root over, you need to first of all you need to make cross multiplication, and then you need to make square both sides. So this will be y1 square into 1 minus x square equal to y1 square into 1 minus x square equal to m into e to the power, sorry, m square into e to the power m square into e to the power m sine inverse x whole square. And e to the power m sine inverse is already y, so I can write y1 square into 1 minus x square equal to m square into y square. Okay, again if I differentiate, differentiating with respect to x, what you get, y1 square into minus 2x plus 1 minus x square into 2y1 y2 equal to m square into 2y y1. So divided by on divide by 2, what do you get? We get 1 minus x square into y2 minus x y1 minus m square y equal to 0. Okay, now let us take this line in the next page. So the last expression is y 1 minus x square into y2, 1 minus x square into y2 minus x y1 minus m square y equal to 0. Differentiating n times and applying Leibniz rule, we get 1 minus x square into y n plus 2 minus nc1 1 minus 2x, only minus 2x into y n plus 1 minus nc2 into minus 2 into yn minus x into yn plus 1 minus nc1 into yn into 1 minus m square yn equal to 0. Okay, this is 1 minus x square into, or 1 minus x square into yn plus 2 nc1, put nc1 equal to n and nc2 equal to n into n minus 1 by 2. So it will be, I'm writing directly that it is plus n into minus 2x into yn plus 1 minus n into n minus 1 into yn minus x yn plus 1 minus n yn minus m square yn equal to 0. I think if you simplify this term, you will get the answer. I am writing the last expression, 1 minus x square into yn plus 2, and this is yn plus 1 term, this is yn plus 1 term. So if I take this 2, then it will be 2n plus 1 times x yn plus 1 and from this 2 I will have minus n square plus m square times yn equal to 0. So this is the last expression. In this way you can find out the nth order derivative. One more thing in this question, that the question was, I need to write the question again. The question was, why it was given y equal to e to the power n sin inverse x, and you have already proved that 1 minus x square times yn plus 2 minus 2n plus 1 times x yn plus 1 minus n square plus m square times yn equal to 0. Okay, now the question is find yn at 0. This type of question is very important when the questions is like you have to give the exam in MCQ. So this type of question is very important. Whenever you have this expression, it is very easy to find out yn at 0. Okay, so what is y equal to m sin inverse x? It is given to you. Now y1 equal to m e to the power sin inverse x into 1. So I think it's wrong. Y is given as m sin inverse x. So y1 as e to the power m sin inverse x into m by root over 1 minus x square. Okay, so what is your y1 at 0? This is e to the power m into sin inverse 0 is 0 into m by root over of 1 minus 0, that is m. Okay, so we have a result here. This is the result. Let me write the result. The result was y2 into 1 minus x square minus x y1 minus m square y equal to 0, and y was e to the power m sine inverse x, y1 was e to the power m sine inverse x into m by root over 1 minus x square. So y at 0 equal to 1, y1 at 0 equal to m. Okay, this is done. So why I need to find out y2. So y2 at 0 into 1 minus 0 minus 0 into y1 at 0. I am putting everywhere at x equal to 0 minus m square into y at 0 equal to 0. So ultimately we get y2 equal to m square, y2 at 0. Okay, now finally just write the final result. This is finally what we get. What we get, 1 minus x square times y n plus 2 minus 2n plus 1 times y, sorry, x n y n plus 1 minus n square plus m square into y n equal to 0. Now I want to put x equal to 0 in this line. I want to put x equal to 0 in this line. So we get yn plus 2 at 0. This will be completely 0 because x equal to 0. If I put the middle term will be 0, and then equal to n square plus m square into yn at 0. Now if I put n equal to 1, n equal to 1, this will be y3 at 0 equal to 1 square plus m square into y1 at 0, and y1 at 0 is already m, so it is m square plus 1 times m. Okay. Let me write that in the next page. Yn plus 2 at 0 equal to m square plus n square times yn at 0. If I put n equal to 1, we get y3 at 0 equal to m square plus 1 times y1 at 0, and this is m square plus 1 times y into m. If I put n equal to 2, it is y, let me put n equal to 3. No, let's put n equal to 2. y4 at 0 equal to m square plus 2 square into y2. At 0. This is m square plus 2 square into y2 is, what is y2? What is y2? y2 is m square. It is m square. n equal to 3. If I put n equal to 3, this is y5 at 0. This is equal to m square plus 3 square into y3 at 0. That is m square plus 3 square into m square plus 1 square. y3 at 0 is given into m. Okay. So in this way you can find all the value, all the derivative at the point 0. at the point 0. So whenever it is yn, so we don't know whether it is odd or it is even. If you just put another one, just find another one n equal to 4, it is y6 at 0 equal to m square plus 4 square into y4 at 0. So it is m square plus 4 square into y4, 0 is already computed, it is m square plus 2 square into m square. Okay, so look at the expression. Whenever it is odd, y3, suppose y3 will contain m square plus 1 into m. Whenever it is even, suppose y6, it contains all the even terms, m square plus 4 square into m square plus 2 square into m square. So let me write the final answer. It is yn at 0 equal to m square times 2 square plus m square, 4 square plus m square, n minus 2 square plus m square if n is even. Look, all the even squares are happening. Same thing is equal to n minus 2 square this is m into 1 square plus m square, 3 square plus m square, n minus 2 square plus m square if n is odd. This is the final answer. This type of question is very important for the exam, that when the last expression, to prove last expression and derivative at a particular point, nth or a derivative at a particular point. Okay, so there is some problem in any textbook based on Leibniz theorem. And one more thing I should conclude with this lecture: the Leibniz theorem is very important topic for your exam.